Welcome to the ICS 3U video about methods. In Chapter 7, which is about methods, we're going to look at using methods as another way to solve our problems and to give sections of code very specific tasks that we can call repeatedly to have the same function or to do the same thing. Before we begin to look at that, we need to look at this top-down development that we've been using for problem solving so far. Up until now, we've been solving all of our problems and all of our programs quite sequentially, meaning we start at the top and we work our way down, and each line as we go down does a different task, or maybe they're related. We could have conditions and we could have loops to repeat a task, but we're going to be looking at methods to have a section of code that we can call as needed and when needed. In the future videos, I'll go over some examples of how we can do this. So right now we have this problem-solving approach that is top-down, quite sequential, quite linear in terms of start and finish with nothing really in between. It does not really break down our programs into smaller subtasks. We'll look at methods and how we can do that. We need to also look at having this first level of subtasks translated into the main method. The main method is all we've been using so far. We're going to start using that main method to simply call other methods and other little pieces of code that we can use. One of our goals is to have our main method as tidy as possible with almost very little code into it. As we look down here at levels of tasks below the main, we're going to create these other methods, and it doesn't matter what order we create them in, it depends on the order that we call them in. And hopefully that again will make a lot more sense as we get into some programs. This quick little slide here, we've got our main method with very little in it, but we can call this little piece of code down here to put in a title. And that's all it's going to do is simply put in a title. This one over here, we could pass something down from the main method, which will get the data. Perhaps it'll calculate wages, and it might display them. And this one over here, we're going to pass down some data. We're going to calculate taxes, and then this method, when it's finished, is able to return something, and we're going to return the taxes calculated to the main method. Again, I hope this will make sense a lot more as we get into our programs. Using methods. As I've mentioned earlier, each method has a very specific task, and a method can only do one task. If it does more than one task, we probably should have used two methods. So we're going to try to be very specific on our methods and very specific on the job that they're doing. The methods are part of a class, and in our programs we'll see that how they're part of a class. A main method defines the first level of subtasks, so this main method of code that we have in our programs, and that's all we've been doing so far, is everything's been in our main method, is going to be calling these other subtasks or these other methods. So using methods to define tasks is called procedural abstraction, meaning each little method has its own procedure and its own purpose for what it's going to do. Here is a method. The method here is called Fahrenheit to Celsius. Also notice our coding conventions with naming methods are the same as when we create variables. Let's go over what this thing does. It's public. So the access level means any part of my program can get to it. It's static. It's not going to do anything. It's not going to return anything to us. It's simply here. It's not going to be giving anything else. Return type is void. Again, it's not going to return anything to us. It's just going to calculate it. It's a fairly contained method. We have our method name, remember following proper coding conventions. And here we have the body of the method. And the body of the method is contained with curly brackets, just like our conditional if statements, just like our for loops, our do loops, or our while loops. If we look here, we simply have two double variables, ftemp and ctemp. We have our scanner input, things that we've all seen before. This is all code that we could do without a method. We're going to use this example to kind of go through it and solve this one task. Method parameters. A method can have parameters for accepting values from a calling statement. We can pass information down to a method. And the beauty of this is that we can pass as many types of variables down or as much information as we want to a method. Parameters are used inside the method to perform the method's tasks. When we're doing this, the method is accepting our data, and data passed to a method is called an argument. So anything going to a method is called a parameter, Anything being received by the method is called an argument. In Java, arguments are passed by a value. A primitive data type gives the method a copy of its value. This will again make a whole lot more sense as we actually get creating our programs. So right now I'm just going to kind of give you a few moments to look at the slide, looking here that an object gives a method a copy of its reference that points to the method for changing object data. Again, hopefully this will make a lot more sense when we get into an actual program. Methods can have multiple parameters, meaning we can pass down more than one piece of data. We could pass down an integer variable, we could pass down a double variable, we could also pass down characters, booleans. However, when we pass it down, the method must be able to receive the exact same type of data in the exact order that it's being passed. And if we look down here, there's a method called drawBar. We have public static void drawBar. It's going to take an integer called length and a string called mark. Method overloading. Now this is kind of weird. Method overloading says that we can have more than one method with the same name. So we can use the same name to call methods. So we could have two drawBar methods depending on the data being passed down and the information that we're sending down. It will know which one to choose. So the compiler uses this type, order, and number of parameters to determine which method to execute. The return statement. Not every method returns something. A return statement is used to send a value back to the calling statement. It can only return one value. So while we can pass multiple values down to the method, a method can only return one value back up to the main method. So a method that returns a value must include the return type in the declaration. For example, the cube of method returns a double, so public static double. If you remember back earlier, we had public static void. A void means that it's not going to be returning anything. Public static double means that it's going to be returning a double variable. A method that returns a value is called from a statement that will make use of the returned value. Really all we're doing here is assigning this variable called cube to the value of whatever the method turns. Documenting methods. I've been trying to stress throughout the course that documentation is extremely important. It gets even more important with methods, and it's very prescribed as to how it should do it. So methods should be carefully commented so that a reader of the program understands the task, if any, that it's going to do. Method documentation should appear just above the method, and documentation should include a brief description of the the method, any preconditions, and the post condition. Precondition states what must be true at the beginning of a method. Postcondition states what must be true after the method, and they should state that they should really be telling you what the method is doing. I'm going to leave off here. I'll go through these last couple of slides. A little flowchart, a little program we've already done. Start, get numeric grade from user, determine and display the letter grade. We might do that one in a method, but you have a different method for each task here. We can get the numeric grade from a user, and we can do that in a method and return it back to the main, and then we could pass down the numeric grade that we get from here, send it to this method, and it can then display the letter grade for us. That concludes this little slideshow about an introduction to methods and some of the terminology and a little bit about how methods work. Doesn't make a lot of sense until we actually get coding it, so I'm going to do a few little examples of coding this, and hopefully that'll make more sense and give us a better idea of how to use them.